Hey everybody, welcome back to another fun and exciting Algebra 2 class. Today we are going to be talking about some really exciting things. I know you're going to have a lot of fun today. Maybe you can tell I'm being a little sarcastic. Today's lesson is a very challenging lesson, so make sure that you pay attention, make sure that you don't fall asleep during the video, and watch it all the way through. Lesson is 4.8. We are going to be translating graphs with parabolas. Basically, the idea is graphing a function. When you graph a function, many times you get a parabola. Well, a transformation means a change. So what we're going to be doing is dealing with changes to the standard form, or what we call the parent form, the parent function of a parabola. We'll get into all that. We are on page number 199. 199. We're going to hit a milestone today. We're going to hit page 200 in your book. That's pretty awesome. So page 199. If you look down here at the screen, I have some key concepts that we need to really discuss before we go into the lesson. The first thing is, what is a parent function? Well, the parent function is right here. It's y equals x squared. And maybe even better said, it's the function of x equals x squared. This is what it's going to look like as a function, okay? This is what it's going to look like. The y is what it's going to look like when you're graphing it. We use y to graph, but then when we get into upper level math, we're going to start using the function of x to graph rather than y. It's the same thing. The y-axis is the function of x-axis. So the only thing that changes is the way that we're labeling it, but everything else remains the same. So this is key right here to understand. This is the parent. In other words, all the other functions are like babies of the parent. Okay, so the parent is the same, it stays the same, and then it has little babies. It has different types of other modifications, if you will, to the parent function underneath of it. All right, and again, some of the stuff isn't going to make sense right now. That's okay. It will make sense in just a little bit. The standard form of parabolas. You need to memorize this. This is so very important to what we're doing. The standard form of the parabola is function of x equals a, parenthesis, x minus h, close parenthesis, squared, plus k. Man, that is super important. Now, you don't know what any of that stuff means right now. Okay, you see an x in there, you're like, hey, I think I know what the x is. You see maybe some other variables, you see a squared, you see some things that are familiar, but you've never seen this before. So we're going to go through it, we're going to talk about it, and hopefully by the end of the lesson you'll understand how this standard form works. Now, the vertex of the parabola, in other words, okay, so we have a graph here, and our parabola is going to be going in a U shape on the graph. The vertex is where the parabola turns the corner and starts going up the other side, okay? And in standard form, well, let's say in the parent form, okay, right here, the function of x equals x squared, in the parent form, the vertex sits at 0, 0. Okay, so the vertex is at 0, 0 in the parent. Now, when we're doing translations, we're going to be moving the parabola left to right, up and down. We're even going to be stretching it, compressing it, doing some other things to the parabola. So, in parent form, it's at 0, 0. But in some of these other forms, it's not going to be at 0, 0. We're going to move the vertex. So I want you to see, notice something right here. Notice in the vertex, it's HK. Well, look up here in our formula, our standard form of a parabola, and you're going to see an H and a K. So when you have your parabola in standard form, you can find the H and K because it's right there. They're going to be numbers. They're not literally going to be H's and K's. But where that H is, there will be a number. That's your X of your vertex. There's going to be a K. There's going to be a number where the K is. That's going to be the Y of your vertex. So these are coordinate points down here. And so it's HK, and that's going to tell you where to put your parabola on the graph. Again, be patient with me, okay? We're going to get to this. Now, two other words that you need to know as we go through this. Rigid and non-rigid. A rigid translation means that the parabola will maintain its original shape, okay? So here was the original shape of the parabola. Now, if I take this original shape of the parabola, I could translate it, and whoops, let me try to get on. There we go. I could translate it, and I just move it on the line left or right. I could also do the same thing up and down. Now, technically, that's changing the shape because I'm not drawing it perfectly, but you get the idea. I'm just moving it, okay? I'm taking the whole parabola, rigid, okay, like it's stiff, okay, and I'm moving the whole thing. I'm not changing my shape. That's rigid. Non-rigid, here's what that means. The parabola will change its shape. So let's say my parabola is like this. Well, now my parabola might be like this, or even more dramatic, okay? Or maybe my parabola is going to go something like this. Okay, that would be a compression where you're pushing it down, you're compressing it. The other one that I showed you is a stretch where you're pulling it up, like a rubber band, okay? So you pull it, okay, you're compressing it, or if you push it, if you're pushing it, you're compressing it. If you're pulling it, you're stretching it. And that's rigid and non-rigid. Those are important words. You'll need to know those for quizzes and tests. The parabola maintains its original shape, rigid. Non-rigid parabola shape is changed. All right. That's fun, right? All right. Next, let's go through the really 4 different translations of a parabola that we have. The first translation is on page number 200. Page 200. This is the vertical translation. Okay, so here's what we're going to do. Vertical means up and down. You'll see that right here. I put on this up and down. Okay, right there. So up and down. This is going to be going vertically. So that means it's going to be transitioning on the which axis? The X or the Y? The Y axis, because the Y goes up and down. So let's go back to the standard form of the parabola. I have it written right here. I have it written several times throughout this lesson so you can remember it. Which one did we say was the y-axis? So let's go back to the original one. This one, the k, was the y variable, right? Okay, because this is where the vertex is. So if the k is 0, then the vertex is going to be at 0 on the y-axis. If the k is 5, then we're going to move the parabola up 5 spaces. So the vertical, the k, moves it up and down. Okay, what do I mean by all that? Let's look at this example of this parabola right here. The function of x equals x squared plus 3. Now you might be thinking, no, Mr. Steve, that's the h, okay? Because I remember the formula. The formula was x minus h squared. So I know that's got to be the h because that's part of, no, look. This one doesn't have an h. In other words, the squared is just with the x. The h doesn't exist on this one. So this one doesn't have an h. So this is actually the k. The 3 is the k. So one thing that you can do here is you can write k equals 3. Well, I just told you that it doesn't have an h. So if it doesn't have an h, then the h is 0. So what's the vertex of this parabola? It's 0, 3. 0, 3. Why? Because the h is 0, doesn't exist. And the k is 3. So what are we going to do on this graph over here? Let's come over here to this, we'll call this a graph. It's not a very good one, but what we want to do is we want to go up 3 positions. And that's where we want to put our point, is up 3 positions. And so our parabola is going to go through that. That's going to be the vertex. What did we do? Well, our vertex used to be down here, right? It used to be at origin. That's where the parent is. Remember, this is the parent. Okay, so on this one, the child, here's the child, okay, we've moved it up 3 spaces. We've moved it up 3 spaces. All right, so that is vertical translation. Now, notice something, it could also potentially go down. What if this was -3? So let's change this to a -3. Well, we also have to now change our k. Our k has changed to a -3. Okay? So what's going to happen is we're actually going to go down 3 positions on our graph. And then there's our new parabola right there. Now we've transitioned it down. Negative, and I've got this, I thought I had it written down here, but I don't. So positive goes up, negative goes down. Okay, and that makes sense on the y-axis, right? Positive always goes up, negative always goes down. Okay, good. Vertical translation is next, the vertical translation. Now, I want you to see something in the original formula. So let's go all the way back up to the original formula here. Let me kind of erase some of this stuff so you can see it a little bit better. I want you to notice that in the formula, it is a negative h. A negative h. That is super important. You're going to have to know that, and it's gonna mess you up multiple times. Some of you, you're going to keep messing up, keep messing up. So learn it right now. Negative h. What does that mean? So let's go back. Now this is what's called a horizontal translation, or it's translating on the x-axis. It's going left and right. I wrote that right here. It's going left and right. So what does that mean? And I said right here, be careful with the direction. Be careful with the direction. Now look, because the formula is a negative h, let's say our h is negative. Let's say h equals -3. Well, when we plug it into the formula, what do we get? We get -3. What does -3 mean? It means +3. That's right. So what's going to happen here is negatives, and this is mind-blowing right here, okay? But negatives, look right here, a negative h goes to the right. A negative h goes to the right. Wait a second. No. Now listen, Mr. Steve, this is positive and this is negative. So I know that the positives have to go this way. Okay, no, because I just showed you. If it's positive, here's what happens. Let's say it's a +3. Well, when you plug it into the formula, you get a negative +3. What's negative positive? Well, it's -3. So a +3 actually goes to the negative side, okay, because of the formula. The formula does that to it. On the x, it's backwards. On the y, it's regular. So positive goes up on the y, but on the x, positive goes to the left. Positive goes to the left. So be careful of that. Let's look at an example of that right now, okay? So here we go. We have this right here. Here is our, notice that it doesn't have a plus k. It's +0. So the k in our formula here, or in our coordinate points for our vertex, is going to be 0. So what is the h? Now be careful. Notice that the original was x minus h. So what is the h here? Well, the h is -3, because if we have -3, that's where that positive comes from. Okay, I know it's like mind blown right there. But the h is -3 in this one. Okay, so we're going to have -3. So now watch what happens on our graph. We're going to come over here, -3 spots. And now this is where our parabola is going to be bending, right there at -3. Okay? H is -3. But Mr. Steve, it's +3. What are you talking about? No, no, no. It's -3 because the formula is -h. Okay? So it does the opposite. All right, next, vertical reflection. Vertical reflection. Well, let's talk about what does reflection mean. Have you ever looked in the mirror? I've got my school shirt on right now. See how I did that? Because I'm looking in my camera. I'm looking at a reflection, so it's actually backwards. When I go like this, I'm seeing that it's on my right side, but it's actually on my left side. And so it's a little bit backwards. Well, when you look in a mirror, it looks backwards. If you take a word and you show yourself a word in the mirror, when you look in the mirror, it looks backwards. Okay? That is what's called reflection. Okay? If you know anything about science, you've studied that before. Refraction, reflection, all those different things. It's the way that the light hits the mirror and bounces it back. And I'm not going to get into all the technicalities of the science behind it, but reflection, reflect. Okay? Now, what does that mean? Well, here's what it means. If the parent goes this way, the child is going to go this way. It's going to be an exact reflection of the parent. It's like you put the parent up in the mirror and it reflects. Have you ever looked at the lake and you look out across the lake and you see the trees on the other side, so you see the trees standing up, but then you also see the trees reflecting in the water? Okay, that's what's going on right here. There's a reflection. Well, where did that reflection come from? It came from the sign of the A. The sign of the A. If the so here's the original again. Here's the standard form. Notice that in this one the A is positive because there's no sign. So when it's positive, it goes up like normal. Notice I put a negative A reflects downward. So let's say that I did have a negative A right there. If I have a negative A, we know that our parabola is going to go down. Let's look at an example of this. Here's one right here. Notice right here I have a negative A. You say, there's not an A there. I don't see a number there. What is in front of every single variable that we've ever had in algebra? Yeah, there's a 1 there, so you can put a negative 1x. Okay, so our A is 1 in this case, but it was negative. So that means our parabola is going to reflect downward. Now notice that in this one, it has no h, so h is 0, k is 1. So we're going to be up 1, because that's a vertical translation. But it's going to reflect down. So this one is going to actually go like this, and it's going to bend downward. Why? Because this negative sign makes it bend down. Okay. Ooh, this is fun. I told you this was going to be fun. There's one more set. Okay, there's one more set. I promise I'm done after this. Vertical stretch and compression. So basically the stretching, remember I told you these are non-rigid. These are the ones, if we go back up here to this word, oh, it's a long ways up here, non-rigid, okay? The other ones have all been rigid. Vertical translation, horizontal translation, and then reflection. Those are all rigid. In other words, the shape of the parabola is not changing. Now in the non-rigid, in the last one here, the stretch and compression, you're going to have the stretch is like pulling it up and the compression is like pushing it down, and it's going to change the shape. Well, in these ones, when your absolute value, this is important, your absolute value of A, so whatever A was, remember in the one that we just had, A was 1, okay, we did this one and A was negative 1. But the absolute value of the negative 1 would be 1. So if it is greater than 1, if the absolute value of A is greater than 1, it's going to stretch it. If the absolute value of A is less than 1, so in other words, if you have a fraction, be careful because the negative and positive don't come into play here. We've taken the negative and positive out when we added the absolute value. The negative and positive have to do with the vertical reflection that we just talked about a minute ago. We're not talking about negative and positive here. So in other words here, if the A is a number bigger than 1, the absolute value, it will stretch. If it's a fraction or a decimal, then it will compress. Okay, so if the absolute value of A is a fraction or a decimal, it's going to compress. Let's look at this. Here's the child, okay, not the parent. This is the one that they give us. This one is compressing by 1/2. Okay, what does that mean? Well, if your parent, let me draw the parent in yellow. So here's the parent. Well, the child in this case is going to compress. It's going to like be scrunched down. Okay? Let me give you another example. And so that was the pink one. Let me give you another example. I'll do a blue one. So example, function of x equals 3x squared. Well, in this one, the absolute value of the a is greater than 1. And so what would happen in this one is it would actually stretch and make it taller. Okay? So this one is, the blue one is stretched, the yellow one is the parent, and the pink one is compressed or pushed down. Okay? And so the compressed ones are going to stretch out sideways. The stretched ones are going to stretch up long ways. They're going to be taller. Okay? Skinnier, if you will. Wow, that was so much fun. Okay, I had fun. I don't know if you did. Lots of information there. I'm sorry it's a little bit longer video. You do need to go back and rewind that. Watch it again if you missed anything. This is important stuff. Go to the end of the book. Go to the end of the chapter there. Practice these so that you can be ready for your quizzes and tests that are coming up. Okay? See you later. Bye-bye.